Hi there and welcome to the fourth lesson on linear functions. My name is Dylan. In this lesson we will be learning how to find the formulae of linear functions when we are only given 2 points that lie on the straight line. By the end of this lesson you should be able to find the formula of a linear function if you know the coordinates of 2 points on a graph. Ntombi and Lerato will once again be helping us in this lesson. Welcome, girls.
Hi, it's great to be back.
In lesson 3, we found the formulae and graphs of linear functions when we were given 1 point on the line. We used the gradient to find a second point. In this lesson, we are given the coordinates of 2 points. A straight line passes through the points 0, 5, and 1 2/3, 0. It is important that we know that the function is linear, because if we are told that a function graph passes through 2 points, that graph could really be any shape. Take a look. The function could be a curve like this, or the graph could even look like this.
But what if we didn't know that the function was linear?
Well, then 2 points are not enough. We need more information. We either need to be told that the function is linear, or we need to know the value of other points so that we can check that the rate of change is constant.
So, because the function is linear, that means the gradient is constant.
And then the graph must be a straight line.
Correct. Do you know how to draw the graph?
Just join the 2 points.
That's right. If we know the function is a straight line, we simply need to join the points. Now, let's find the formula. Because we know that the function is a straight line, we know that its formula is of the form y equal to mx plus c. In order to find the formula, we need to know the values of m and of c.
In the last lesson, we knew the value of m, the gradient, but now we don't.
But the 1 point has x equal to 0.
Well spotted. That means we have the y-intercept of the formula. We know that the value of c is equal to 5. Therefore, we know that our formula is of the form y equal to mx plus 5. What we now need to do, though, is to find the gradient or the slope.
I know. Use the other point where x is equals to 1 2/3 and y is equals to 0.
Yes, here we have the coordinates of another point. And because this point lies on the straight line, we know that it must satisfy our equation. In other words, we know that 0 is equal to 1 2/3 multiplied by m plus 5.
I sometimes struggle with mixed fractions like that.
Okay, how can we rewrite the fraction so that it's easier?
Don't we need to write it all divided by 3?
Correct. 1 2/3 can be rewritten as follows. We know that 1 is the same thing as 3/3. Therefore, 1 2/3 must equal 3/3 plus 2/3, which is simply equal to 5/3. So our equation becomes 0 is equal to 5/3 multiplied by m plus 5. Now we can easily solve for m. Lerato, can you do this?
Yes, subtract 5 from both sides. Now, multiply both sides by 3/5.
That's correct. Now remember that minus 5 divided by 5 is equal to minus 1. So we have that minus 1 times 3 is equal to m. Therefore, that m is equal to minus 3. So our formula is y is equal to minus 3x plus 5. Let's look at the graph again. Now we can write in the formula y is equal to minus 3x plus 5. In the previous lesson, we worked with graphs that had positive gradients. In this case, the value of m, or the rate of change, is negative. In this example, we were given two very specific points. We were given the graph's intercepts with both axes. This is the y-intercept, and this is the x-intercept. We can say that this method of finding the formula of a straight line function is the intercept-intercept method, or dual intercept method, where dual means two. Now, let's find the formula of a function that passes through any 2 points. Here the graph of the function h passes through the points 4, minus 7, and minus 2, 5. Now we need to find the formula of the function. And to begin with, we know that the function is a straight line. Therefore, the formula is of the form y equals mx plus c. But in this case, we do not know what the gradient is, and we also don't know what the y-intercept is. So we need to find values for both m and c. Let's see if a table of values will help us to do this. Here are the 2 points that we know the graph passes through. When x is equal to minus 2, y is equal to 5. And when x is equal to 4, y is equal to minus 7. Because the function is a linear function, we know that the rate of change is constant. Let's see if we can find this constant rate of change. For a rate of change, we look at how the output values change when the input values change by 1. So let's fill in the input values. Now, from where x is equal to minus 2 to where x is equal to 4, that is a total change of 1, 2, 3, 4, 5, 6 units. Now let's see how the output or y values have changed. From where y is equal to 5 to y equal to minus 7, that is a total decrease of 12 units. For the total of 6 units that the input values have changed, the output values have decreased by 12 units. But in order to find the rate of change, we need to find out what the change in the output values is for each unit of change in the input values. In other words, we need to distribute or share the 12 units of change of the output values equally amongst the 6 units of change in the input values. We must share the minus 12 equally between the 6 units of change that occurred in the input values. So for each 1 unit change in the input values, the output decreases by 2 units. It's a change of minus 2. Now let's see if this change of minus 2 each time is correct. 5 minus 2 is 3, minus 2 is 1, minus 2 is minus 1, minus 2 is minus 3, minus another 2 is minus 5, subtract another 2, we get to minus 7. So the decrease of minus 2 in the output value 6 times does in fact give us a total decrease in the output values of minus 12. So we know that our change of minus 2 is correct. The rate of change of our function is -2. Remember that the rate of change is the gradient. So in this case, the gradient or the value of m is -2. Let's fill that in. So we know that in our formula, y is equal to -2x plus c. Now we need to solve for the value of c, and to do that we can simply substitute in the coordinates of one of our points. I'm going to use this point over here, -2, 5. So now we know that 5, that's the y value, is equal to -2 multiplied by the x value of the point, -2, plus c. Therefore, 5 is equal to 4 plus c. Therefore, c is equal to 5 minus 4. Therefore, c is equal to 1. And so our formula is y is equal to -2x plus 1.
It's the same we did in the previous lesson. We used a point.
But we have 2 points. Why can't we use the other one?
Well, let's check. Let's use this other point here, 4 minus 7. If I substitute this point into our equation, we get minus 7 is equal to -2 multiplied by 4 plus c. Therefore, -7 is equal to -8 plus c. Therefore, -7 plus 8, if we add 8 to both sides, is equal to c. Therefore, c is again equal to 1, exactly the same answer as we got in the previous calculation using the other point.
Wow, so we can choose the point.
That's right. What else is important to remember is that there is only one straight line that can pass through 2 specific points. So if we work accurately, we will always find just one formula. Now, there is another check that we can do. We know that for the y-intercept, x is equal to 0. Have a look at our table. Here, when the y values constantly decrease by 2, we found that when x was equal to 0, y was equal to 1. So after working through the table, we already knew that the value of c was equal to 1. But remember, it's always wise to check our calculations just like we did.
Bye.
We hope to see you again.